All right, algebra friends, we're gonna go over Pythagorean theorem, Unit 3, Assignment 1. We went over this, or you guys should have went over this in 7th grade. So I'm gonna just go through the questions. For these videos, I only have 15 minutes, so I can't teach the whole thing. But if you watch this video, go through the vocab, we'll send you another link from a guy that I like on YouTube to teach it. But if we go through the questions together, we should get a decent grasp on how to do it. So let me write on this. So as long as we remember a squared plus b squared equals c squared, we'll be good. And now we just have to figure out why we do that. Is we have a triangle and the opposite side of the right angle will always be the hypotenuse. So this is always going to be c. A and b don't matter in a sense that this could be a, or this could be b, and this could be a. They can flip flop, but c can't. So we're just trying to figure out what is a, what is b, and then we see if we have c. So it says find the length of a hypotenuse. So we're trying to find the length of c of a right triangle with the legs 8. So say this is 8 and this is 15. So we have 8 squared plus 15 squared equals c squared. 8 times 8 is 64 plus 15 times 15 is 225 equals c squared. Okay, add those up. 64, I'm not a mental math guy. 982 equals c squared. We can never leave this as a square. We have to do the square root or radical. So square root it. And when you do that, if we come over here, the calculator, let me move it. We can do, where's it at? There it is. 289 radical or square root of 17. So our answer would be 17. Okay, number 2 says find the length of the hypotenuse of a isosceles right triangle with the legs, whose legs are 1 unit in length. So we got this. Something like that, and it says isosceles, so that means 2 sides are the same. And if it's 2 sides that are the same, it's going to be the 2 legs, because c of the hypotenuse is can't be the same as these 2. So this one's going to be 1, and this one's going to be 1. So essentially, we just got 1 squared plus 1 squared equals c squared. This is 1 plus 1 equals c squared. 1 plus 1 is 2 equals c squared. Do the square root, or do the radical, do the square root, and then we're just left with, for this one, it looks like they just want us to leave it like that. You got to look at the question, look at the answers, and see if they want you to simplify it more. But this one, we're just going to have the square root of 2. Number 3, you guys can do it on your own. It's just 4 squared plus 5 squared equals c squared. Number 4 says the hypotenuse of, so this one is giving us the hypotenuse. So it's saying instead of a squared plus b squared equals c squared, it's still the same thing, but now we don't know one of the legs. So one of the legs is the square root of 13 plus we don't know one of them, so we'll just say b squared equals 7 squared. This should be the square root squared. So when we do, just like how we do c squared equals 9, if we do the square root or the radical over it, they cancel out, and we're left with just c equals, do to both sides, we're left with 3. So for this one, once we have both of them, they just cancel out, and we're left with 13 plus b squared equals 49, because 7 times 7 equals 49. So just like we've done all year, when we solve for a variable, we get it by itself doing the opposite operation. So subtract 13, we got 6, Lauren's calling me, and 4 minus 1, we got 3, so we got b squared equals 36, and we can do the square root, and b equals 6. Number 5 says, which of the following sets could be the sides of a right triangle? So for a right triangle, they have to, when you do a squared plus b squared, they have to equal c squared. So if I finish with 14 equals 14, perfect, that could be a right triangle. If I finish with like 5 equals 25, that doesn't work, and it's not a right triangle. So we got 5 squared plus 8 squared equals 12 squared. And the 12 is C because C is always the longest, or the biggest number is C. So we got 25 plus 64 equals 144. So these two right here have to add up to 144, and that's 9, and that's 8. So 84 does not equal 144, so that can't be it right there. So let me clear this. Let's try C. So we got 3 squared plus 5 squared equals square root of 34. So we got 9 plus 25 equals square root. Oh, this should be squared too. So when that happens, these cancel out, and we're just left with 34. They cancel out, and we're left with 34. So 25 plus 9 is 34 equals 34. And since they equal each other, that will be a right triangle. All right, number 6 is pretty, you guys can do that on your own. Pretty easy, I was gonna say. 7 is just the square root of 10 and the square root of 15 equals c squared. I'll do that with you guys, or I'll set it up for you guys at least. So we got 10 squared plus 15 squared equals c squared. So these cancel out, and I'm just left with 10 plus 15 equals c squared. 10 plus 15 is 25 equals c squared. The square root of it, and you get your answer right there. All right, we got a little word problem for number 8. So it says contestants in a long distance race run 5 kilometers due south. So we're going down 5. The runners then turn right and head west towards the finish line. So it's the finish line. If the straight line distance from start to finish is 13, so from here, straight line to here is 13, what is the distance that the contestants traveled while heading west? So we don't know this. So we can say this is B. So we have A, we don't know B, and we have C squared. So it's just 5 squared plus B squared equals 13 squared. Then it's 25 plus B squared equals 169. 13 squared, 169. Then you subtract 25 because we have to get this B by itself. We're left with B squared equals 144. Square root of B, cancel that out. Left with B, square root of both sides, equals 12. Good there. All right, this last one here says complete the equation below by writing an expression equivalent to length of A, the leg of the right triangle. So all we're doing, there's an answer right there already for some reason. But if we're trying to solve for A right here, we have to get A by itself. So we just subtract B to both sides, B squared, and then we're left with A equals C squared minus B squared. There's a couple of ways we could do it. If we wanted to move this back over there, we would go that way. But the answer is just C squared and B squared in there.